Hi అండి, నేను మీ ప్రియాంక. వెల్కమ్ టు లర్నింగ్ లెన్స్ ఛానల్. Today we are going to discuss exercise 2.2 problems. What is the question? We need to find the zero of the following quadratic polynomial. Here in the question it is given a quadratic polynomial. For that quadratic polynomial we need to find the zeros, and later we should verify that using the coefficients of the polynomial. We already know how to verify the coefficients of the polynomial. Again I will explain. Okay, x square minus 2x minus 8. So this is the question given. So let us compare this with ax square plus bx plus c. So what is the value of a into c? A means here nothing is there, so let it assume as 1. So in the a place 1 is there. 1 into, in the place of c it is minus 8. So don't consider the negative signs, just consider the only the coefficients. So 1 into 8, 8. So what are the factors of 8? So 1 8s are 8, 2 4s are 8. Still any more? No. So if we use these factors, if we add or subtract these factors, we should get the middle term. If we add or subtract these term, so we should get the middle term. So if I take this one, I am not getting the middle term. Suppose 8 plus 1, 9. So I am not getting the middle term. 8 minus 1, 7. I am not getting the middle term. So see this, 4, 2. 4 minus 2, how much? 2. So when I am subtracting these two, I am getting the middle term. So I am going to use this only. Okay. So x square minus, so here minus is there. So we should keep minus for the bigger term. Minus 4x plus 2x minus 8. So in these two, what I can take common? X. So what is left here? So x square. So we can write x square as x into x. Take x as common. So what is left here? Another x minus. So I took x as common. So what is left? Minus 4 plus 2. I took 2 as common. So what is left here? X. So 8 we can write it as 4 into 2. So already we took 2 as common. So minus, what is left here? 4. So in these two, what is common? X minus 4. And so I am writing x minus 4 as outside. So what is left here? X plus 2. So x minus 4 into x plus 2. X minus 4 is equal to 0. X is equal to minus 4, when it goes to other side will become plus 4. X plus 2 equal to 0. So plus 2 when it goes to other side will become minus 2. So alpha value is 4 and beta value is minus 2. So here zeros of the quadratic polynomial are 4 and minus 2. Okay, now we are going to verify the relationship between the coefficients. So let us compare this with this. So ax square plus bx plus c. So I am comparing this with this one. 1x square minus 2x minus 8. Okay, I am comparing this with this. So what is a value here? 1. B value here? Minus 2. C value here? Minus 8. So what is the sum of the roots value? Alpha plus beta. That is, what is the sum of the roots value? Alpha plus beta is equal to minus b by a. So this is the relationship between the zeros and the coefficients of the polynomial. So using this I am verifying. So what is b value? Minus 2. So already minus is there, and so I am keeping minus. Minus of minus 2. What is a value? 1. Minus into minus plus. So 2 by 1. So alpha plus beta value is 2 by 1. Next, alpha, beta. So product of the roots is c by a. This is also the relationship between the zeros of the polynomial and coefficients of the polynomial. What is the value of c? Minus 8. Value of a? 1. So minus 8. So let us verify this. So what we got here? Alpha 4. Beta is minus 2. So alpha plus beta, how much? 4 minus 2. That is equal to 2. So we got here 2. So here also we got 2 only. So here and here, in both places we got 2 only. So what is the value of alpha beta? 4 into minus 2. That is equal to minus 8. Here also we got the alpha beta values minus 8. So hence verified. Both in both cases we got the answer same. So we can say that it is verified. The relationship between the zeros of the polynomial and the coefficients of the polynomial is verified. So we can write the relationship between zeros and coefficient of polynomial is verified. Okay, understood? Next problem. Same, we need to find the zeros of the polynomial and we should verify that. So what is that? 4s square minus 4s plus 1. So again I am comparing this with ax square plus bx plus c. So what is the value of a into c? A value 4 and c value is 1. So a value 4 and c value 1. So 4 into 1 is 4. So write down the factors of 4. 1 into 4 and 2 into 2. So 2 into 2 is nothing but 4. So I am taking this. Why? Because when I add or subtract, I should get the middle term. So when I am using minus 2, I will get minus 4. So that's why. So in these factors, which factor we should take? We should take the factor such that when we add or subtract these factors, we should get the middle term. Okay. 4s square minus, in the place of 4s I am taking minus 2s plus 1. So in this both what I can take common? 2s. So 4s square we can write it as 2s into 2s. So 2s I took as common. So what is left here? 2s minus 1. So I took here common as minus 1. So what is left here? 2s. So when I took common here 2s, what is left here? 2s. I wrote here minus as it is, and 2s already I took a common, so value is 1. Here I took common as minus 1. So minus 1 I took common. So what is left here? Only 2s. So here what is there? Plus 1. So already we have took here common as minus 1. But here plus 1 is there. When opposite sign is there, so we should add with the same sign. So minus into minus plus. So I am writing minus 1. Why I wrote here minus 1 but here it is given plus 1? Because we already took here minus 1. Common as minus 1. So to make it as plus 1, I am making this as minus 1. Minus 1 into minus 1, how much? Plus 1. Okay. Next, take these two as common. So 2s minus 1. Both are same only. So I am taking 2s minus 1 as common. So what is left here? 2s minus 1. So how it is it? 2s minus 1 whole square is equal to 0. So 2s minus 1 is equal to 0. So 2s is equal to minus 1 goes to other side will become plus 1. So 2s is equal to 1. That implies s is equal to 1 by 2. So s is equal to 1 by 2. Now we are going to verify the zeros of the polynomial. So already we have wrote 4s square minus 4s plus 1 is equal to ax square plus bx plus c. So what is the value of a? 4. What is the value of b? Minus 4. What is the value of c? 1. So value of c is 1. So value of c is 1. So what is the sum of the roots value? Alpha plus beta is equal to minus b by a. Minus of, so b value how much? Minus 4. So I took minus and inside minus 4. A value 4. So minus into minus plus 4. 4 by 4, that is equal to 1. So alpha beta, that is product of roots. Alpha beta is nothing but product of roots. That is equal to c by a. What is c value? 1. A value 4. So 1 by 4. So let us verify this. Here we got alpha and beta value as 1 by 2 and 1 by 2. Why? Because here repeated root. So alpha is equal to 1 by 2 and beta is equal to 1 by 2. So alpha plus beta how much? 1 by 2 plus 1 by 2. That is nothing but I took common as 2. So what is in the numerator? 1 plus 1. 1 plus 1 is nothing but 2. 2 by 2 is 1. So what we got here? Alpha plus beta value 1. So in this case and in this case, in both cases we got alpha plus beta value as 1. Next alpha beta value 1 by 2 into 1 by 2. So 1 by 4. So here alpha beta value is 1 by 4. Here also alpha beta value is 1 by 4. So the relationship between the zeros of the polynomial and coefficients of the polynomial is verified. Hence verified. Next problem, 6x square minus 3 minus 7x. So compare this as ax square plus bx plus c. But here ax square is there, bx square is this. So ax square is here, bx here and c here. So let us write in an order form. That is ax square, bx, c. So I am writing this as ax square plus bx plus c. So now it is in the order form. So first of all, for any problem we need to check the order. Is this in this order or not? X square, x and constant term. If this is not in this order, first write down that one in the order. So a into c. What is a value here? 6. C value here 3. So 6 3s are 18. So what are the factors of 18? 6 3s are 18 and 2 9s are 18. So when I subtract 9 and 2, I will get 7. So I am going to use this factor. So 6x square. So here minus is there. So in the middle term minus is there. So I am keeping the big number negative sign. Minus 9x plus 2x minus 3. So in these two what we can take common? 3x. So 3 into 2 is nothing but 6x. So 3 into 3, 9x. So I am taking here common as 3x. So what is left here? 2x minus 3 plus in these two I am taking common 1. So what is left here? 2x minus 3. So in this both what is common? 2x minus 3. So what is left here? 3x here plus 1. So 2x minus 3 is equal to 0. 2x is equal to 3. So x is equal to 3 by 2. And here 3x plus 1 is equal to 0. 3x is equal to minus 1. So x is equal to minus 1 by 3. So here what are the alpha and beta values? Alpha is equal to 3 by 2 and beta is equal to minus 1 by 3. Okay. So what is the alpha plus beta value here? 3 by 2 minus 1 by 3. So 2 3s are 6. LCM is 2. Take LCM. 2 3s are 6. So cross multiplication. 3 3s are 9. Minus 2 into 1, 2. 9 minus 2 how much? 7. So 7 by 6. Next alpha beta. Alpha value is 3 by 2. Beta value is minus 1 by 3. So numerator and denominator 3 will get cancelled. So answer is minus 1 by 2. So let us verify this is true or not by using the coefficients of the polynomial. So from this we know ABC values. Using this expression we can write ABC values. So A value is 6. B value is minus 7. C value is A value 6. B value minus 7. C value minus 3. So alpha plus beta is nothing but minus b by a. So this is the relationship between the zeros of the polynomial and coefficients of the polynomial. So minus. So what is b value? Minus 7. A value 6. Minus into minus plus. So 7 by 6. What we got here? 7 by 6. Here also we got the same value, that is 7 by 6. Now verify the product of the roots alpha beta. So alpha beta value is c by a. What is c here? Minus 3. A value 6. So 3 1s are 3 2s are. Minus 1 by 2. Here what is alpha beta value? Minus 1 by 2. So here also we got alpha beta value as minus 1 by 2. In both the cases we got alpha plus beta and alpha beta values same. So both are same. So we can say that hence verified. Okay, understood? So next problem, 4u square plus 8u. So here I am taking common 4. Why? Because 8 we can write it as 4 into 2. So I am taking common 4. So what is left here? 4u I am taking. So u square we can write it as u into u. So I am taking common as 4u. So what is left here? U plus, so what is left here? 2. U plus 2. 4u into u plus 2 is equal to 0. So u is equal to 0 first and u plus 2 is equal to 0. So u value minus 2. So what are the alpha beta values here? Alpha is equal to 0 and beta is equal to minus 2. Here alpha is equal to 0 and beta is equal to minus 2 we got. So what is alpha plus beta value? 0 minus 2, that is minus 2. So alpha beta value 0 into minus 2. 0 into anything is nothing but 0 only. So we got sum of the roots value as minus 2 and product of the roots value as 0. So we are going to verify this with this equation. So this equation is of the form 4u square plus 8u. So let us compare this with, so c constant term is here 0. So I am comparing this with ax square plus bx plus c. So I am comparing this equation with ax square plus bx plus c. So what is a value here? 4. B value 8 and c value 0. So what is alpha plus beta value? So sum of the roots is minus b by a. So the relationship between the zeros and the coefficients of the polynomial is minus b by a. So minus 8 by 4. So 4 ones are 4 twos are. So what we got here? Minus 2. So alpha plus beta value here we got is minus 2. Here also we got the same. So the equation is verified. Next, alpha beta value. So product of the roots. Value c by a. C value is 0. 0 by 4. So 0 by 4 is 0 only. So alpha beta value here we got as 0. Here also we got it as 0. So hence verified. This equation is verified for the zeros of the polynomial and coefficients of the polynomial. Hence verified. So next problem, t square minus 15. So in this, t square minus 15 is equal to 0. So t square is equal to 15. So t square is equal to 15. Square when it goes to other side will become root. T is equal to root plus or minus root 15. When square will goes to other side, so here we will get two values, that is plus and minus. So t value is root of 15 plus 15 and t is minus root 15. So here alpha value is plus root 15 and my beta value is minus root 15. So what is the alpha plus beta value? Root 15 minus root 15. So plus root 15 minus root 15 how much? 0. So alpha beta value how much? Root 15 into minus root 15. So take minus as outside. So root 15 whole square. Square root get cancelled. That is minus 15. Okay. So we are going to verify this equation for the zeros of the polynomial and coefficients of the polynomial. So take this equation t square minus 15. So here t term is not present. So write it as t into 0 minus 15. So compare this equation with ax square plus bx plus c. So what is a value? 1. B value 0. C value minus 15. So what is alpha plus beta value? Minus b by a. So b value how much? 0. Say 0 by 1, that is 0. And alpha beta value is c by a. So c value how much? Minus 15. And a value 1. So minus 15. So what here we got alpha plus beta value? 0. Here also we got 0. And alpha beta value here we got as minus 15. Alpha beta value here also we got minus 15. Hence this equation is verified for the zeros of the polynomial and coefficients of the polynomial. Hence verified. Understood? So next question, 3x square minus x minus 4. So I am comparing this with ax square plus bx plus c. So what is a value here? 3 and c value here 4. So I am taking the only numbers but not the signs. So A value is 3 and C value is 4. So A into C, that is 3 4s are 12. So what are the factors of 12? 2 6s are 12 and 3 4s are 12 and 1 12s are 12. So which factor we need to choose? We should get the middle term. So I am choosing the middle term. So whatever the sign is here, that sign should be for the greater number only. Okay. So 3x square minus 4x plus 3x minus 4. So minus 4x plus 3x is minus x. But here 3x, 4x. So there is nothing to take common. So I am interchanging these two places. When there is nothing to take the common, we can interchange the values. So 3x square plus 3x minus 4x minus 4. So in these two, what I can take common? 3x. So what is left here? X plus 1 minus 4. So what is left here? X. So plus 1 I am taking. Why? Because minus into plus I am getting minus. So whatever the sign, we should take here the opposite sign. So minus 4 into 1 minus 4. So what is common in this both? X plus 1. 3x minus 4. So x plus 1 is equal to 0. So that implies x is equal to plus 1. When it goes to other side, will become minus 1. So 3x minus 4 is equal to 0. So minus 4 when it goes to other side will become 4. So x is equal to 4 by 3. So what are the alpha and beta values we got here? Alpha value is minus 1 and beta value is 4 by 3. So we got alpha value as minus 1 and beta value as 4 by 3. Then what is the value of alpha plus beta? Minus 1 plus 4 by 3. So nothing is there, take it as 1. So 3 into 1 is 3. So cross multiplication. 1 into 3, 3. Minus 3. So minus is there, I am writing as minus 3. 1 into 4, 4. So minus 3 plus 4, how much? 1 by 3. So alpha plus beta value is 1 by 3. Now what is alpha beta value? So alpha beta value is minus 1 into 4 by 3. So minus 4 by 3. So alpha beta value is minus 4 by 3 and alpha plus beta value is 1 by 3. Now, so we are writing the relationship between the zeros of the polynomial and the coefficients of the polynomial. So alpha plus beta is equal to minus b by a. Let us compare with this equation and say the ABC values. What is a value? 3. B value? Minus 1. C value? Minus 4. So alpha plus beta value is minus b by a. So minus into minus plus by a. So 1 by 3. So what we got here as alpha plus beta? 1 by 3. Here also 1 by 3. Both are same. Now alpha beta. What is alpha beta? C by a. C value is minus 4. A value is 3. Minus 4 by 3. So alpha plus beta value is 1 by 3 and alpha beta value is minus 4 by 3. So in this case and in this case, in both cases we got the answer same. So the relationship between the zeros of the polynomial and coefficients of the polynomial is verified. Hence verified. Okay, understood? If you like my content, please like, share and subscribe. If you click on the like button, it will reach to more people and students. Then it will be encouragement to me and then I can do more and more videos. Thank you for watching.